Yeah. So if you have linear expansion, and I actually should have written down the equation here, you have delta L equals alpha L initial delta T. So if you have linear expansion, it's just 1 alpha. What about area expansion? 2. And then volumetric would be 3. So basically, you're just changing what alpha you're using here. So you say A equals 2 alpha A naught delta T. And change B equals 3 alpha B naught delta T. And what about the units for delta T? Kelvin. Kelvin, yep. But can you use Fahrenheit or Celsius? Right. Well, you can use Fahrenheit, but your coefficient of thermal expansion would need to actually specify it.
Oh, I see.
Per change in Fahrenheit.
But Celsius is okay.
Yep. Celsius and Kelvin for a change in temperature are interchangeable. So if you're told that some sort of pipe goes from 10 degrees C to 20 degrees C, that's a change in temperature of 10 C. If you convert that to Kelvin and figure out what that is, it's going to be a change in temperature of 10 Kelvin. So you can work in Celsius or Kelvin for this. Just something to keep in mind. Make your life a little bit easier. You don't have to switch to Kelvin all the time.
Okay. Keep it in Kelvin or Celsius, but if it's Fahrenheit, we need to convert it.
Yep, and you can convert it just to Celsius. You don't need to figure out what it is in Kelvin.
Okay.
Okay? I also didn't include an example question for this one. Do you want me to make one up, or do you think you're good with this?
That's fine. See.
Okay. Let's see. Okay, so you want to figure out what substance is a long thin pipe. So you know you're going to have linear expansion first of all. But you don't know what material this is. So alpha is unknown. But what you can do is measure what the initial length is, and then expose it to, and I specify this is 5 meters, and then expose it to a change in temperature of, say, a whole 30 degrees C. You want to really measure this precisely so you make the number very large. And you find out that the L final is 5.02. What is your alpha?
So is that like a board? It's like a minor board?
Yeah, something like that. Like a pipe, I guess. No, just use linear.
Okay.
Yeah.
What do we use area?
If you have like a cookie sheet, something like a flat metal disc, maybe.
Okay.
So I guess the point is, with the cookie sheet or flat metal disc, it's so flat that the initial length in some direction is very, very small. So it's not going to change very much. Your cookie sheet is not going to increase in width or in thickness very much. It is going to increase a little bit, but not very much. However, the other two dimensions, the area, is large enough that you have to take that expansion into account. For a pipe or even a board, I guess, you have the cross-sectional area is very, very small, and all you have to worry about is the expansion in the length. So that's why you can use linear expansion or area expansion in some situations.
I think that's talking about linear expansion.
Okay.
So I'll first talk about like how much it expands or how much it shrinks, right?
Mm-hmm.
Is it always like when you increase the heat, does it always expand? Or does it depend on the material?
So in general, if you increase the amount of heat or increase the temperature, it will expand. However, there's one substance that doesn't. You know what that would be? Sorry? Actually, I'm not really sure about mercury, but one common substance, I wouldn't say mercury is terribly common.
Water.
Yeah, water when it's close to freezing.
Yeah.
Expands when it decreases in temperature. And then starts to decrease again. It starts to contract again as it gets more and more cold. But for a small part of the pressure, temperature, volume scale, you have an increase in volume for your decrease in temperature. But water is really the only common material. Yeah. So we've got one answer. Any other?
1.3 times 10 to the negative 4.
1 point what?
1.3 times 10 to the negative 4. I get that too.
All right, so we've got 2 answers. Pretty good. So you have, first got to figure out where to go with that one. And so you have 0.02 meters equals alpha 5 meters at 30 degrees C. So, that makes sense. So 0.02 divided by 150 equals 1.37 minus 4.
Here? Yeah. Oh, rather.